Hello everyone, this is Korndanai. I am Senior Sales Engineer. I am delighted to welcome you today to SCI Virtual Exhibition. I am here to present you refrigerant in the future and global overview of refrigerant regulation. I will focus on the refrigerant for air conditioning application. Hope you enjoy the presentation and find the information interesting and helpful. Climate change is one of the biggest challenges of our time. It has already happened. It's a 95% chance that human activity is the cause. Temperatures are rising, icebergs are melting, sea level is increasing. Vital signs of the climate change are in every corner of the world. We also been burning more and more fossil fuel like oil and coal, and this releases carbon dioxide. As you see in the graph of global emission by gas, carbon dioxide is the most greenhouse gas emitted by human activity. On the other hand, if you see global emission by economic sector, electricity and heat production is the largest single source of the global greenhouse gas emission. Industrial processes and refrigeration contribute the emission of F gases. This includes hydrofluorocarbon. Even though F gases is the smallest percentage of the global emission by gas, it is more potent than carbon dioxide. Thousands of times worse released into the atmosphere. They accelerate global warming and create a hole in the ozone layer. To mitigate climate change, we must reduce or prevent the emission linked to the human activity. In refrigeration business, it is crucial to look for environmental friendly refrigerant. Refrigerants are classified to different groups by their chemical composition. These are fluorocarbon and natural. The eco-friendliness of a refrigerant can be measured by its ozone depletion potential or ODP and global warming potential or GWP. Fluorocarbons are synthetically produced. The classification also depends on their chemical elements: chlorine, hydrogen, carbon, and fluorine. The first one is the ozone depletion. CFC and HCFC refrigerants were widely used in the 20th century. However, these refrigerants are being faded out because it was discovered that they have both high ODP and high GWP. For non-ozone depletion, there are HFC and HFO. HFC is widely used today, but it has a high GWP. For FFO, this is another preferred choice, which is categorized as having zero ODP and low GWP, and offering a more environmental friendly alternative to CFC, HCFC, and HCFC refrigerant. If we talk about natural refrigerant, they have a low GWP and are efficient, and we expect them to become popular refrigerant soon. Whenever possible, though safety will still be a limiting factor in regulating the usage of natural and some SFC or SFO refrigerant. Move to the historical cycle of refrigerant. Actually, it all started with ammonia. It was first used around 1834, but because it can cause fainting, so it was faded out of the home appliances. Then when safer artificial options called F-gases were developed. The first generation were CFC and HCFC. In early 1970s, scientists noticed that a giant hole in the atmosphere. It was discovered that CFC and SFC refrigerant cause a breakdown of the ozone layer. Therefore, we could mobilize the protocol that required to agree on strong ozone protocol. Consequently, the Montreal Protocol was established in 1984. In addition to reducing the ODP load in the atmosphere, the reduction of CFC emissions had also considerably decreased the global warming impact. Substitute refrigerant called hydrofluorocarbon have zero ODP and medium to high global warming potential. However, their GWP is still lower than the phased-out CFC type. Due to the growing threat of the climate change, usage of HFC has been rising to reduce the impact on the environment. In October 2015, the party of the Montreal Protocol agreed to phase out for HFC. The phase out came into effect in 2019 and will help significantly reduce the use of high GWP gases. Here we see an overview of the HFC phase-out step. The Montreal Protocol now has two categories to control ozone depletion and global warming potential. It is mentioning that developed countries called non-A5 countries, while developing countries called A5 countries. A5 countries are divided into two groups, including China. It belongs to the early group represented by the black line, while the brown curve represents India and Middle East countries. The non-A5 countries are also divided into two groups, with a gray curve representing the North America countries and Japan. And the green line curve stands for Russia and many of its neighbors. The EU phase-out is represented by the red line and is already begun. The EU phase-out will not be affected by the Montreal Protocol phase-out, since HFC emissions have already decreased by approximately 40%. Here is the broader overview of the refrigerant. If you look at the application that currently use R410A, you can see that there are many opportunities to substitute this refrigerant that has a GWP value of 2,500, and it is considered a base refrigerant. For example, R466A is a close matching to R410A in terms of efficiency in cooling capacity and non-flammability. But the complicated production R466A means it will not be a cheap solution. Therefore, it seems likely that high-pressure systems will move to A2L refrigerant. There are already opportunities in the market to substitute R410A with low GWP refrigerant, such as R32, R452B, and R454B, that need to be carefully designed into the system and carefully handled by installer. We believe that long-term sustainable refrigerant solution is the key. We consider 6 main parameters that must be aligned to accomplish a real sustainable balance. When choosing a new refrigerant for application, all 6 parameters must be considered together to achieve long-term and sustainable results. It is important to look at the many underlying parameters such as maximum unit efficiency, safety, climate change, ease of conversion, ozone layer protection, and efficient use of resources. We are focusing on lower GWP refrigerant. R32 and R452B have the same level of the GWP value, but if you see the efficiency and economy. R32 stands out as the best alternative. Refrigerant with ultra-low GWP will be important in the long term. R454B is another choice, even though its efficiency is slightly lower than R32. To make it capable of developing new sustainable solutions for the new refrigerant, SCI has developed a model that includes all the main parameters. We will discuss the way forward as focus on exploring the refrigerant group and application. What is going to happen in the near future for the air conditioning sector? RAC or PAC and VRF systems will gradually shift away from using R410A and toward R32, R454B, and propane. A2L refrigerant is expected to be used in higher capacity, but needs some safety endorsement. For bigger systems such as coal chiller and rooftop unit, a similar transformation to A2L refrigerant is happening. The efficiency and capacity of the equipment using new refrigerant like R454B is also good and equivalent or even better than when using R410A. Before we end the presentation, let me introduce product lineup of SCI compressor. R32 became a popular refrigerant for air conditioning. We have a wide range of capacity for fixed-speed compressor. Start with rotary compressor. Its capacity starts from 2 kW up to 18 kW. For scroll compressor, its capacity starts from 20 kW up to 35 kW. And then I will show you R32 inverter compressor lineup. The capacity starts from 1.5 kW up to 18 kW for inverter rotary compressor, and 6 kW up to 100 kW for inverter scroll compressor. Refer to research of broader overview of the refrigerant. R454B will become another popular refrigerant in the near future. SCI also has rotary inverter compressor which are compatible with the refrigerant. Capacity range from 1.5 kW up to 15 kW and 2 kW to 35 kW capacity for scroll compressor. Here in SCI, we have a wide product range and serve almost all refrigerants, including the natural one. If you are looking for a partner to develop a more environmental friendly product and contribute a cleaner solution to the world, SCI is your answer. Thank you.
Wow, thank you so much for the presentations. I love how you explain the refrigerant 10 from the very beginning and take it step by step, very easy to follow, all the way to the future 10 of the refrigerant again. So I love that. So for the first questions, it will be related to the refrigerant 10. So do you have the propane compressors, the R290 compressor?
Yes, absolutely. Actually, we have developed propane compressor for European market for the heat pump application. Its capacity starts from 1.5 kW up to 25 kW.
All right. All right. So for the next questions, this one. So can you give some ideas on why the trend of the refrigerant for the air conditioning applications move to the A2L refrigerant?
Okay. According to the main refrigerant available in the market, Actually, we have R466A, but it is complicated in terms of production. That's why it's still not popular in the market.
Oh, right. I see. So, for the next questions, I think this one will be interesting, and I think everyone will want to know about this issue. So, what is the difference between the R32 and the R452B?
Because the GWP slightly the same value and property, but R452B is very rare in the market, so it's not a preferred choice for the unit manufacturer.
Alright, I see. So the trend is gonna go with the R32 for now. Alright, for the next questions, give me one sec. I think this one is very interesting. So, what is the difference in terms of the structure design of the compressors when comparing the R410A and the R32 refrigerant?
So, if you see the property of R32, it has pressure higher than R410A. So the sizing of the compressor for the R32 is smaller by approximately 7%.
Right. So for the question number 5 is, this one is kind of related to the previous questions, and it kind of like the following question here is, what do we have to change in the system when we change the refrigerant from the R410A to the R32?
You can drop the compressor in the unit. You charge amount of the 32 refrigerant lower than R410A. So air conditioning manufacturer can reduce amount of the refrigerant charge and the sizing of the condenser, which help you save the cost.
Alright, so you save more using the R32. Alright, thank you so much for all your answer. It's short and clear. So if you have any further questions, leave it in the live chat, and we will see you with the next presenter.